आज हम लोग फर्स्ट बैलून सॉल्व करने वाले हैं एंड दिस क्वेश्चन आई हैव सॉल्व मल्टीपल years ago, yeah, in 2023. So it's been more than 2.5 years, I guess. Yeah. तो इस क्वेश्चन का अप्रोच तो बिल्कुल इट्स अ हार्ड क्वेश्चन, तो इतना आसान भी नहीं है. सो बेसिकली इस क्वेश्चन में हमें we have the array, and this array basically represent number of balloons. Okay, so basically we have balloons here, here. Okay, and we have to burst the balloon, and by bursting the balloon we will get some points. Okay, and let's say if you are bursting this balloon 1, the points you will get is basically nums of I minus 1 into nums I into nums I plus 1. So basically multiplication of these three, 5 into 1 into 3, so that would become 15. Okay, so the approach, if I remember correctly, was that we will try for each sub-array. Okay, let's say this is the sub-array, and we will start from the very bottom. That okay, if this is the sub-array, okay, this is the sub-array, and 1 is the last element to be get busted. So let's say 5 is already busted, all other values are busted in this sub-array. Let's say this sub-array is of larger size. Okay, let me make a sub-array of larger size. Let's say this is the sub-array. Okay, and at any given point we would be solving for a particular part of this array. Okay, so let's say we are solving from range this equal and this. So left is here and right is here. Okay, so this is the sub-array we are solving for. So first we won't solve for 1, 5, 8, not like that. What we will think, let's say all other sub-arrays are busted, and let's say this is the last element. Suppose 5 is the last element to get busted, so that means these two are already busted and these three are already busted. Okay, in that case 5 is the last element to get busted. So what is the point we will get? We will get something like 5 into 8 into 5, right? So you understood what happened. So basically what has happened, that 5 will get multiplied by if say left pointer is here, 5 will get multiplied by left minus 1 into right plus 1, right? So this would be the case. Similarly this 5, similarly we will consider for 8, for 3. So let's say this is the sub array at given point. So we will write a loop for int I equal to left, I less than equal to right, I plus plus, and then answer equal to nums of I into nums of, so left is here, right is here, so it would be left minus 1 into nums of right minus 1. Okay, and we are doing this in loop. So let's say we initialize our answer with 0, and answer would be basically max of answer into this one. Understood what is happening? So we are basically thinking that okay, what we will get if this is the last element, what we will get if this is the last element, if this is the last element. Okay, so we are solving like that, and at the end, because we are in a loop and we are checking for each possibility, we will simply take the max out of that. Okay, so, and of course we will apply DP later, but let's first write the recursive solution and then we will try to memorize it. So let me just make a, and what are the constraints? I don't know if we have to take long or something because we are multiplying. Nums I 100. I don't think so. 100 into 300, so would be 30,000, right? Okay. If 300, all elements are 300. Sorry. Okay. Number of elements can be 100, and each value of nums I can be 100, and there can be 300 elements, right? So 100 into 300 can be the max multiplied value, which is fine. I think int is fine. Okay, and we will get a left and we will get a right. And if left becomes greater than right, that means we are done, right? And after that we have our usual solution, which we can put here. Correct. And we can simply return okay. So we have the value for each, but along with that we have to solve the remaining partitions, right? So remaining partition would be helper nums. So left will remain as it is, and since we have solved for I, the right would go as right minus 1, right? And then we have to solve for right partition, I plus 1 and right, I minus 1, I plus 1 and right. Fine. Now one more thing, we are doing left minus 1 here, right? And left would be 0, and similarly we are doing right minus 1. So in that case it will give us error that array index out of bounds, because it will try to fetch elements from here and here. So either we can do that, if left is 0, then we can handle like that, or we can simply do int, we can define a new array, okay, with right, new nums 0 would be 1, so we have fixed the left and right boundary as 1. Okay, you understood why? So basically we can't put 0, otherwise it will become 0. So let's say this is the last element, 3 1 5, 8 all are busted, 5 is the last element. So the point we should get from 5 is 5, right? But if we put 0 here, it will become 0. So 5 into 1 into 1 would be 5. That's why we are initializing them with 1. And then new nums of I plus 1 equal to nums of I. So we are just copying this entire value here, but the zeroth element of nums we are copying on 0 plus 1, like first element. So here till here we are done, and just we have to call this particular function. So we have to return helper, it would be new nums, left would be, so now left won't be 0 because we are sending new nums. Left would start from 1. Let's see if it passes the basic test cases, then we will try to memorize it. If left greater than right, return 0, fine. Answer equal to 0. Left I minus 1, I plus 1, right. What are we doing wrong? Oh. So basically, let me see. New nums dot get minus 1 would be last element. That would be up to minus 2. Oh, we have to initialize 2 variables, right? Oh, we have to increase the length by 2. Let's see. Int new nums, new int nums dot length plus 2. This is fine. New nums 0th element is 1. New nums dot length minus 1 is 1, fine. Okay. New nums I plus 1 equal to nums I. This is iterating through entire array. This is also fine. New nums 1. Left and right pointers are correct. New nums dot length minus 1. Minus 1 will point to 1, but we want the right pointer to be minus 2, which is fine. Okay, now we have left and right. What if left is equal to right? That means we have only one element, but we have to burst it, right? I smaller than equal to right, I plus plus. This is also fine. Nums I to nums of left plus 1. Nums of right plus 1. Nums I into nums of left minus 1 into nums of right plus 1. I think this was wrong. Okay. Now let's try to memorize it. So we have 2 variables, if you see, left and right. So okay, int of dp equal to new int n, and we can pass dp here. dp, pass dp here, dp here, dp of left and right equal to answer. Now we can try to convert into iterative solution. So as we discussed earlier, we will just use our recursive solution and convert into iterative ones. So we won't change anything till we have initialized our DP. Okay. And we have to change our return statement. So our return statement will, because we are not going for recursive solution, so helper won't exist anymore. So instead of this, we will just put DP. Okay. Now we have to write two for loops, left and right. Okay. So this is the box which we have to fill now. For int left. Okay, so starting point of left was 1 earlier. So now it would be the reverse. We will start from the last. Left greater than equal to 0. Okay, why 1? Because we were starting from 1. So from 1 we were going till nums.length minus 2. So we will do the reverse. Okay. Similarly for right, for int right equal to, now this one we will start from 1, right smaller than new node length is n, and it should go till n minus 2, so n minus 1, right plus plus. Okay. Now we have our two loops ready. Base cases we will see, which is left greater than right, then okay, let me just code it. If left greater than right, from this is coming. Okay, so if left greater than right, return 0. So because we are doing iterative, we will just put dp of, we can just continue. Let me just put, we will see if we can remove it, because anyway the value will be 0, but as of now I'm just putting, and we can continue from here. We don't need to solve. So this part is handled now. This is not required, and this is the core logic we will just put inside our loop. Alright, we can remove this function, and now it is done. Okay, let's try to run it. Oh, sorry. So once we have copied it, we can't call helper, so we will use the same indexes. So instead of helper, we will just put dp. All right. So because we were using nums here, but we were passing new nums, so that was handled. But in this case, we have to make it new nums. We won't be using nums anywhere. Alright, so basic test case has passed. Let's try to submit it. Okay, now we are beating 92% of solutions. Oh, okay, so the base submission till now is 38 millisecond. Space, it is taking more. Why? Why? Because we have a DPR in both cases. We are avoiding recursive stack. Anyway, I have to check on this. Fine then, I think we have solved it with both recursive as well as iterative solution. So we will meet